think I told you to leave a space for study goal number 42. I think your study guide said I'm going to add a bunch of stuff here. I want to remind you of something that I've said throughout the year. The College Board is focused on solutions. For any problem they're going to ask you, they're also going to ask you how to solve that problem. And some of those descriptions of the problems can get really complicated. I try really hard to emphasize the connections between people and other people on our planet and distant behaviors with distant consequences. But the solutions is a big part of the AP exam, and you can always flip through your units and put little green post-it tabs so that you can remember green for go. These are the solutions that we should use. So here's the solutions to air pollution broken up into a few separate lectures like this one. First, I want to talk about controlling particulates, and I'll just give you a couple of examples of this, and then I'll make separate videos for controlling cars and factory stuff. Okay. So government requires that likely polluters capture particulates. Think of all the places that make particulates. It's a good list for you to know. Power plants, because of the fossil fuels and stuff. Factories, because they're breaking material and sticking material and using a bunch of energy. Lumber mills, because they're making big pieces of wood into little pieces of wood with a bunch of dust left over. All of our vehicles, and in your house, what makes a lot of particulates when you burn a lot of energy at once, like wood burning stoves or furnaces. So it's not rocket surgery. The brain figures out, the government figures out who are the likely emitters, and we regulate them. And there's different solutions for different technologies, but the idea is collect all the particulates so you can dump them out later and keep them from going in the air. This doesn't prevent the particulates. It lets you trap them so that you can deal with it. Usually we put them in a landfill. Some particulates are useful. Like at a lumber mill, the sawdust is useful for making wood glue or fillers or whatever. Anyway, this is one that you probably understand because you've maybe seen the old school vacuum cleaners. They're like upright with a handle, and they have like a bag, and you unzip the bag, and inside there's like a paper sack. The idea is you force air through a fine mesh, and particulates are bigger than the hole, so they get stuck in the mesh. The air that comes through has been filtered. This is the simplest air quality control. Usually this is for big particles. So this is what they do over at Caleb Chadwick's wood shop. This is what you do in your house when you run a vacuum cleaner. And usually these are really, really, really big. They'll often have shakers so that the mesh fills up and then it's shaken and all the particulates fall and you dump them and then you run more emissions through, clean air comes out. When the filters get clogged, you shake them. So there's this part that I think has shown up on an AP test once called a shaker, which moves the filters in a baghouse. Common for big stuff. There's two separate names for the same idea. So you force dusty air into a cyclone or a settling chamber, and that is forced in at like the side of a tube, so it starts to spin, right? And so you use centrifugal force to get all the particulates out to the edges, and then just plain old gravity, they settle toward the bottom. And then that air on the inside has lost the particulates because centripetal force. And so as you're forcing in more dirty air, the clean air from the middle is forced out. It's probably good to write down this explanation, the centrifugal force and then the gravity settling of particulates. This is really common for fine particulates. um, like factories, power plants, and it's that thing you see on big trucks. You've seen these before. It's a way to force all of the diesel particulates to stay in the thing that you can dump out every so often. The last particulate control is a slightly technical explanation, but you can do it because you understand what electrostatic cling is. I know that you do. You know, like clingy fabric? You know, like you put it in the dryer and it has static and then it sticks to you funny. So what happens is one charge is meeting the opposite charge. Your body has a lot of water and so I don't know, whatever. Opposite charges. And so when you have two things of the same charge, they will repel each other. When you have two substances of opposite charge, they attract each other. You've probably played with magnets. So this is kind of like making dust magnetic. Probably want to write that down. Particulates pass through a metal grid here. And so that gives the particulates a charge. In this diagram, it's negative. So all of those particulates passing through an electromagnet are charged first. You have to know that this is multiple steps, and that number one is to charge the particulates. And now that those particulates have a charge, all we need is the opposite charge. And now that you've made them magnetic, you stick them to a magnet, right? So then those charged particles go past oppositely charged surfaces, right? And that will attract like a magnet. See, the negatively charged particulates stick to positively charged plates. So every day you turn off the plates, all those particulates settle down and you can go dump them out. This is a really big whoop to remove heavy metals because metals are really easy to charge. And so this is a really big deal for burning dirty fossil fuels. Coal burning power plants use these, factories, industrial stuff. And I want to give you a heads up that that's all the particulate controls you need to know for now. But I've got a study goal coming up later that controls a different type of air pollution that will also work on particulates. So you might want to leave like a little blank in your notes. And when we do the other when we do the other air pollution controls, I'll be like, oh, and that also helps with particulates. Okay,